Hello again and welcome to the Bex EDM YouTube channel. It has definitely been a while, but I have made some changes and am now able to spend more time on creating cool YouTube video content. So if you are new to the Bex EDM YouTube channel, this channel is all about electromechanical design and engineering, rapid prototyping and all sorts of cool technology stuff. So if you're interested in those kinds of things, definitely subscribe. Now today's video is about the world's first DIY wire EDM lathe. But before I dive into details, let me first ask you a question. What do these two tools have in common? Well, you haven't guessed it by now. These two tools are the ones you are most likely to find on the desk of a mechanical engineer. And the same holds for me. I use these tools all the time. In fact, I use them so much that I have a whole bunch of them. Well, at least I have a whole bunch of these L-key hex sets. Another whole bunch of these Mitutoyo calipers because those are too expensive for that. But anyway, these L-key hex sets, I use them a lot, like every single day. I have multiple sets and usually when I grab a set off my desk, one of them is missing because it's, I don't know, lying around somewhere. But because I have a bunch of these sets scattered around the shop, I usually find the size that I need. But that gave me an idea because I use this so frequently. What I actually want is like an everyday carrying version of this set, so that I can carry it in my pocket and that I don't lose them, that I always have them around with me. Which gave me an idea. This is the pocket knife that I carry with me every day. The Victorinox Cyber Tool. A fine piece of Swiss engineering. And what I like about this pocket knife is that it has tool bits that you can use with it. 4mm tool bits. So this is the default bit set that comes with the Victorinox Cyber Tool. And although these bits are nice, the ones that I have Torx ends, I don't use them that much. However, if they would be hex ball heads, then I'm quite sure that I would use those bits every single day. So I have been looking around to find bits with hex ball heads, but I'm quite sure that those do not exist. Which leaves me only one option. I need to make those myself. So here's the first bit that I designed in Fusion 360. This bit can be used for socket head cap screws with sizes M3 on this side and M4 on that side. So the dimensions of this bit are that the shank is 4mm, the small ball here is 2.5mm and the larger ball here is 3mm. Then the second bit that I designed is also for socket head cap screws of sizes M5 on this side and M6 on this side. So these dimensions here is the shank is of course also 4mm to fit in my pocket knife. And then on this side the ball is also 4mm, so same diameter or same dimensions as the shank. And on the other side the ball is 5mm. So now that I have designed the tool bits that I would like to have for my pocket knife, I need to make them. But making these tool bits is not easy, especially because these tool bits need to be made from a very hard steel. Because if you were to make them from a soft steel, they would wear out way too fast. And machining hard steels, especially in the home shop, it's not an easy thing to do. Luckily, however, I have built my own wire electrical discharge machine. Now, if you do not know what wire EDM is, or EDM in general, basically, EDM uses the power of electrical arcs to erode away metal. And this allows you to machine or cut any kind of metal with any kind of hardness with a very high precision. This is a wire EDM machine and it uses a wire to cut through the workpiece. This machine can make two-dimensional cuts in the XY plane. And cutting hardened steels on this machine is super easy. So logically I would like to use my own wire EDM machine to make the tool bits that I would like to have for my pocket knife. However, this machine can only cut in the XY plane and the tool bits are round. So currently this machine does not have the capability to machine the tool bits that I would like to have. So I would like to make an add-on for this machine, an additional axis that would allow me to machine round parts, but only when I need to. So I would like to have an add-on that I can just place into the machine whenever I need to make a round part, and then when I would like to make like a normal flat part again, then I can take the rotary axis out. So that's what I will be designing, building and using to cut the tool bits that I would like to have. So here's the CAD design of the rotary EDM axis that I came up with. So this whole assembly bolts to the work surface of my wire EDM machine. Here it is depicted inside my wire EDM machine. This is the window that I use to make YouTube videos through. So you can see here is the spindle, and this is a ER25 collet chuck spindle. So it receives the standard collets that I can use to clamp my work. And the upper nozzle, the upper wire guide here clears the collet chuck. So yeah, you can use this assembly to realize a rotating axis to wire EDM round parts. Now this design was actually not my first design. I made a couple of iterations. I will elaborate on the earlier versions in a minute. So what makes this design a bit special, so some special features in this design is, for instance, this water connection. The bearings inside this bearing block are not sealed from the water environment. These are full ceramic bearings. And in order to make sure that the dirty water, which is polluted by the metal particles, doesn't get into the bearings, the bearing block is under positive pressure by clean water. So the bearings are continuously flushed. Another feature is that the frame, so this part and this part and this part, those are electrically isolated from the work table, which the isolation is made by this layer of plastic. And the motor is also isolated from this plate. There's a isolation disc here, which is 3D printed, and the fasteners are not drawn in this CAD model, but the fasteners are also shrouded in plastic to make sure that there is electrical isolation between the motor and this plate. Because everything is electrically isolated, apart from the main axis, which should be connected to the work table, because the shaft transfers the EDM current, everything else should be electrically isolated to make sure that it does not get eroded. So these parts are all made from aluminum. It would be best to make these from stainless steel, but then it gets kind of expensive and it's harder to make. So I made those parts from aluminum and made sure that the aluminum got a heavy anodization. Then they last long, but they only last long if they have an electric potential which is floating and not connected to the positive or negative EDM output terminals, because then even if the aluminum is anodized, the aluminum will get eaten away. So these are all isolated and the motor is isolated, and the shaft is basically the only part that's connected to the work table. Now I had some previous iterations which didn't work out. Let's have a look at those and the problems that I encountered. So for my initial design, I wanted to make use of standard steel bearings because they are cheap and readily available. Now the problem with using steel bearings is that if you have EDM current flowing from the inside ring to the outside ring, the bearing will be ruined in a couple of minutes. Because the EDM current will actually EDM the balls inside. So in order to prevent that current from flowing from the inside to the outside, I decided to use a bearing block that's made of plastic. Then the outside ring is isolated and currents cannot flow. So that seemed like a good approach. However, this whole thing needs to run underwater. And steel bearings do not like water, they will rust really fast. Which means that you need to seal the bearings from the water environment. So I designed in these seals to keep the water out, and then the whole bearing block could be oil filled to keep the bearings running smoothly. Now I had a lot of problems with that. First of all, the oil kept leaking out. I even applied a thin layer of silicone to the inside of my parts, but the oil kept leaking out, so oil leakage was a problem. And the second problem was that these standard seals, they actually provide a lot of friction to the shaft. So much actually that my servo would overheat just spinning the shaft in these seals at a few hundred RPM. So there was a lot of heat getting generated in the seals, and the oil was leaking out, so I didn't like that. And another problem was that although I have a really nice 3D printer, FDM printing these parts wasn't really accurate enough to make the bearings run smoothly. Because after mounting a bearing on this side and on this side, once I started giving these bearings some pre-tension, they weren't running nicely anymore because there was a slight misalignment between the two sides because of a printing error. I tried to correct for that, but eventually this was just giving me way too much problems, and I decided to ditch the concept of making a plastic body. So this is the first idea I came up with in order to transfer current from a fixed world to a rotating world. So here we have a bronze contact which wraps around the axis with a half moon shape. I wire EDM this part, and it is connected to the fixed world through this 3D printed part. So this fixed world contact is electrically isolated, and it's pressed onto the shaft, and then the shaft can rotate and the contact stays put. And that's what can transfer the current from a fixed world to a rotating world. So this is the initial idea I had, and I immediately made it. And after I had made it, I came to the realization that it had some downsides to it, which is why I eventually chose a different concept. Now, there are two things wrong with this concept, and the first thing is that although this is soft bronze and this is stainless steel, the stainless steel will wear, not just because of friction, but also because there are quite large currents running through this part. And this stainless steel shaft, this part, is not easy to make, and I don't want to wear it. So there's a problem here. If any parts wear in the concept, then they should be cheap to make and easy to replace. So yeah, clearly this concept lacks in that sense. Another problem with this concept is that so this whole assembly spins on the water, and if it spins at a certain RPM, then water will get drawn into the gap between the fixed world and the rotating world. And what will happen is you will get a hydrostatic effect, which means that the fixed world contact will actually lift and start to skate on the water film in between the fixed world and the rotating world, causing a bad contact. So clearly that's not desirable. So I had to ditch this concept and come up with something else. Okay, let's have a look at some of the parts I made. So instead of a radial loaded wire contact, I made an axial loaded wire contact, which you see here in the picture, at least the brass part. The brass part is the part of the axial loaded contact that is connected to the rotating world. The other two parts here are a clamping ring and the pulley for the belt drive. This is part of the axially loaded wire contact that is connected to the fixed world. It has 3 pins which will hold springs in place, such that this whole assembly is spring loaded and pressed against the other part, which rotates. This is the ER25 collet spindle that I made from 304 stainless. This is the bearing block with full ceramic bearings. And this is the servo motor that I'm using to drive the spindle. These are some 3D printed parts, so the splash guard for the belt, isolation bushes for the fasteners, and the block that mounts the fixed world wire contact. This is the aluminum motor mount with heavy anodization, and the aluminum was anodized by Riano Eindhoven, which really helped me out by anodizing all aluminum parts you see in this video. They did an amazing job, and I can definitely recommend them if you have any parts that need anodization in the Eindhoven area of the Netherlands. This is the base plate, also anodized. And finally the plexiglass isolation layer for isolating the base plate of the work table. So now it's time for a nice montage for the assembly. But for assembly I need a tool, a special spanner for this slotted lock nut that I do not have. It's a special size. So I'm taking a small detour here from the rotary EDM and first making the spanners with my wire EDM. So I finished the special sized spanners that I need, and boy, I cannot tell you how convenient it is to have a DIY wire EDM in your shop. So now that I have these, let's start the assembly. So I got this set of ER25 collets, and the set is fairly inexpensive, 80 euros. But actually these are made of standard tool steel, and these will likely corrode very fast in the EDM environment. However, the same set made from stainless steel would be more than 10 times as expensive as this set. So I wanted to give it a shot with this cheap set by trying out bluing this steel and see how long it will hold in an EDM environment. The same holds for the collet nut. This is not stainless steel, although advertised as stainless steel on AliExpress, but it's magnetic, so it's not stainless. I will try to blue this as well. And then yeah, let's see how it will hold in an EDM environment. So before bluing the parts, they need to be thoroughly degreased. So I'm putting them in my ultrasonic cleaner, which contains isopropanol alcohol. So after bluing, I washed them with cold water, then I blowed them dry with compressed air, let them rest overnight, not sure if that is necessary, and then next day they looked like they could use some WD-40, so I applied that, and this is the final result. Looks nice, but let's see how it holds over time. So here my wire EDM lathe axis is mounted in my wire EDM machine. It's bolted to the work table with my standard stainless steel clamps, though I had to isolate my clamps by adding a small 3D printed piece of plastic in between to make sure that the base, the anodized aluminum base of the lathe accessory is electrically isolated from the work surface. This prevents corrosion. Now that my EDM lathe accessory is mounted, its rotary axis is not perfectly aligned with the x-axis of my wire EDM machine. To correct for that, I take two measurements by probing with the wire. These measurements are spaced apart. And then with a special software tool that I wrote, these measurements are used to calculate which transformation is required to correct for this misalignment. That transformation is then used in the CNC system, and then the axes are perfectly aligned by software. And finally, we have the EDM lathe operation in action. So I was purposely flushing with a really low pressure to show the nice effect of the material chipping away and creating smoke. There are some lines wobbling around instead of straight cuts because I was trying all sorts of different parameters and rotational speeds and things like that. Just to get acquainted with the lathe process for my EDM machine. Because there are quite a few parameters that you can tune to try and make things better. In the end, I settled with a rotational speed that was actually a lot lower than I was expecting. This made the servo behavior less nervous, because any kind of slight runout needs to be compensated for by the servo for the y-axis. But the end result was quite nice. Happy with that result. It was only a test piece, and now I wanted to make something useful, like the tool bits that I designed for my pocket knife. So I got two scrapped pieces of metal, one broken tap and one broken mill bit, which are really nice steels, and decided to use those to make my tool bits from. So here we go, let's make some tool bits. And there you have it, my finished M3 M4 hex ball tool bit. As you can see, there are different shades of oxidation. That depends on the length of time that side spent in the EDM process. And for this part, the final operation is cutting it off. And of course I also made the M5, M6 version of this tool bit. I did not capture that on video because the process was exactly the same. Here I'm cutting it off, and then both tool bits are finished. Here are the finished tool bits. They look a bit rusted and ugly, but that's only very superficial rust. A quick brush clears that off immediately. And here are the finished bits next to their originals. One small problem I had is that the original bits have ball detents and my bits don't. I cannot make ball detents in hardened steel, so my bits would just fall out. To fix that, I glued a very small magnet into the bottom of the holder, and that keeps my bits firmly in place. Final thing I wanted to share is that after 1 hour of machining, the collet and the collet nut did not look corroded. Although 1 hour in EDM time is not that long, but it gives confidence that this might be a nice solution. Okay, that almost wraps it up for this video. I would like to note that the mechanics for the EDM Lathe axis that you've seen in this video can be downloaded for free from baxedm.com. In fact, I open source all my mechanical designs. So not just the EDM Lathe axis, but also the CAD model for my complete wire EDM machine can be downloaded for free from baxedm.com as well. That's my design philosophy. I open source all my mechanical designs, and then if people want to make their own EDM machines, they can build their mechanics themselves, and then they can purchase the electronics from baxedm.com, mainly the arc generator, which can be used in various types of EDM machines. Now, there have been quite a few individuals who have built their own EDM machine based on baxedm designs and electronics, and who are using their machines happily every single day. Now, personally, I think my wire EDM is the most valuable tool that I have in my shop. If you think a wire EDM would be a great addition to your shop too, why not consider building your own wire EDM machine? Building your own wire EDM machine allows you to tailor the machine to your own specific needs. And you can make all sorts of cool variations. For instance, the rotary EDM lathe that you have seen in this video today. So that wraps it up for this video, and see you next time.